For example number 3, we are given a right triangle that looks like this, where this is x, this is y. We're told that this is 26 degrees and this is 14. And we're asked to find x and y. So first of all, let's identify the parts of the right triangle. This is the hypotenuse, right? Why? Because it's across from the 90-degree angle. My angle 26 is here, so this is the opposite. And the leftover side is what we call the adjacent. Now, one thing that we talked about before, and I just want to remind you guys, is Sohcahtoa is the mnemonic device that helps us remember the 3 basic trigonometric functions. So Sohcahtoa means that sine of an angle, we'll just call it theta for today, is equal to the opposite over the hypotenuse. So if you can't remember Sohcahtoa. Sine is equal to the opposite over the hypotenuse, and cosine of some angle theta is equal to the adjacent over hypotenuse. So we would say that this is theta. And if you guys can't remember, theta is a Greek letter. It's just a variable. It could be x, y, z, whatever. I didn't want to use x because we're using x here and we're using y here. So this is just some angle. We could call it whatever we wanted to. I could have called it angle A, angle B, but you got to get used to theta because as you get into the upper level math, that's going to be important. And then yesterday we talked about tangent of an angle is equal to the ratio of the opposite over the adjacent. Okay, so then if I look at this image, to solve for x and y, I see that sine of 26 is equal to the opposite, which is x, over the hypotenuse, which is 14. And then cosine of 26 is equal to the adjacent, which is y, over the hypotenuse, which is 14. So now that I've got that set up, I can find these values by just plugging them in the calculator. So I'm gonna do this one first. Sine of 26, I just got to make sure that my calculator's in degree mode, and I'm just going to hit sine of 26 degrees, which you can't quite see there. Trying to get that so you can see it. There we go, that's better. Sine of 26 is 0.3 or 0.44, let's say that. So this is going to be 0.44 is equal to x over 14. And then to solve for x on this one, if I'm dividing x by 14, then I just do the opposite. I multiply by 14, and whatever I do on one side, I got to do on the other. These 14s cancel out, and I get x equals 14 times this number, which gives me 6.14. Roughly. Okay. Now to do the same thing over here, I'm going to hit clear, and I'm going to say cosine of 26 and that gives me 0.89 stuff, 0.98979 dot 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 is equal to, well, let me write that down a little nicer and neater. first thing in the morning I gotta wake up and do this stuff. This isn't fun. 8, 9, 8, 7, 9, that's good. Equals y over 14. Again, just like on the other problem, if I have 14, that's, in other words, y is being divided by 14. To get rid of the 14, I do the opposite of divide, which is multiply. Whatever I do on one side, I have to do on the other. So I'm going to multiply this by 14, and I get 12.6 roughly. And those are my two answers. Okay? So just to recap real quick, we're given a triangle where the measure of this angle is 26 degrees. I identify the sides. The hypotenuse is across from the 90-degree angle. The opposite side is across from the angle that we're given, and the adjacent is the remaining side. Sohcahtoa tells us that sine is the opposite over the hypotenuse. Sine, opposite, hypotenuse. Cosine is the adjacent over the hypotenuse. C-A-H. Cosine, C. Adjacent, A. Hypotenuse, H. And then tangent is the opposite over the adjacent. Tangent is the opposite over the adjacent. We're asked to find x and y, so we know that sine of 26 is equal to x over 14, the opposite over the hypotenuse. We know that cosine of 26 is equal to the adjacent over the hypotenuse, or y over 14. We do some algebra and we get x is equal to 6.14, and that y is approximately 12.6. Actually, this is approximately 2, because we did some rounding there. Okay?